In this application, we're going to look at the Acuity AP820-20 model, and here's the laser sensor, and I've just got it mounted on a stationary fixture, and here we have the target, and the intent is to measure the height of this target to approximately 12 microns or 10 microns type accuracy. And so what we're going to do is we're going to go ahead and look at this is the profile output, as you can see on the screen. Here is the beveled edge of the part and the top surface, and here we have underneath it a flat white ceramic plate, and this is typically just that, or I should say this is the flat plate right here, and this is the metal base of the part. So here you can see the white ceramic, and there's a dip here and it drops off. And so what we're going to measure is the height, which will be from this surface to this surface of this target. And as you can see with the AP820-20 model, we are using a CCD detector, and because of that, we're getting a really good profile of this shiny metal part. A lot of times I give a lot of regular laser sensors with a CMOS detector a lot of problems, and here you can see we're measuring that edge, and it looks, the data looks very good. Typically this laser will be able to measure from 53 millimeters to 73 millimeters from the face of the laser, or the 20 millimeter depth of field. The linearity of this will be right at plus or minus 12 microns, or plus or minus half a 10,000ths of an inch. So let's go ahead and look at this measurement. We haven't really done any calibrations or anything which will show you that you can do. And this is our little Acuity View software program that we're using, and it has a lot of features that we can do. In this case, we're gonna call it feature measuring, and we're gonna add a new feature. And so what we're interested is in this surface here, and we're going to look at this, and then we're going to look at, here's the other surface. And so what we're going to do is we're going to go ahead and make a definition of this. I mean, we could measure the width of this, right? So we could measure from this point to this point width-wise, but instead we're going to look at the Z, which is the height. And we're going to take an average. So we could take right or left data, but we're going to take an average of these two datas, right? So it's averaging over this box, all these features. And let's just take a larger look at the number that we're getting. And so here you can see that we're measuring a height of 13.372 millimeters. And it kind of gives you a pretty good feeling of where that resolution is. And like I say, once again, fixturing isn't the best, but you can see that we're holding within a couple microns of resolution on the target. And of course, as I move that, you can see how the box, pretty much will follow that. If I can keep it in that same plane, right? So still holding really good data, and with the right fixturing, this would be looks like a very easy application to be able to measure this target and this surface, to give a height measurement, non-contact, very fast and very accurate.